Hello, everyone. This is just a summary of Module 5, topic called hydraulics. Hydraulics means moving something by means of a liquid. It can be water or the oil, but this liquid must be under pressure. Principles, you must be able to define a pressure. A pressure is defined as a force applied per unit area. And the formula will be P. This is the symbol used to calculate pressure. From the definition, it's a force, so it's F divided by A. So this force must be in newtons and the area must be in square meter. So it's a force per unit area. And a force over a square meter is equivalent to a Pascal. A force must be in newtons and an area must be in square meter, and this is equivalent to a Pascal. So at the end of your calculation, you just put PA, which is the SI unit of a pressure, a Pascal. You must be able to define this SI unit called Pascal. SI unit is a Pascal and is defined as a pressure equal to 1 Newton per square meter. A Pascal is the SI unit of a pressure equal to 1 Newton per square meter. From this general formula, when you make a force the subject to cross multiply, and the force will be equal to PA, and this is called the force of pressure. Pressure multiplied by an area. An instrument that is used to measure a pressure is called a gauge pressure. Maybe you've seen this gauge pressure in fill-up station that indicates the pressure that is inside the tire. The hydrostatic pressure laws. So you'll be calculating the hydrostatic pressure. Hydro means, or the terms hydrostatic means the liquid that is at rest. You can be calculating the pressure exerted by the liquid that is stored in a tank, in a swimming pool, in a reservoir, or in a dam. So this pressure is at rest. You can be calculating the pressure or the height, or you can be calculating the density of the unknown liquid. Remember, we can be using a liquid or the oil. Now, if you are given a closed container and it has a pressure, you are given its pressure, a gauge pressure is indicating what is the pressure of what is inside. You can determine, if you know what is the height of the liquid, you can determine what type of liquid is there. Now, the hydrostatic pressure laws, the first one is also called the Pascal's principle. Pascal's principle states that if a pressure is applied at the surface of a liquid, the pressure will be transmitted in every direction with the same magnitude. So a pressure in a closed system acts in the same magnitude in all directions. That is Pascal's principle. The second law, or the second principle, hydrostatic principle, states that pressure is always perpendicular to the plane on which it is acting on. And the third one states that pressure in a liquid is proportional to the depth of the liquid and its density. So pressure depends. When we have a column, a liquid column, a pressure that is inside depends on what type of liquid is there, which is the density. It also depends on gravitational acceleration. What planet are you on? It also depends on the level of the liquid that is inside, which is the height of the column. So it is proportional. Pressure exerted by the liquid depends on three quantities. It is the density, gravitational acceleration, and the height. Number 4. If 2 points in a static liquid are at rest at the same height, they will experience the same pressure regardless of the shape of the container. So the fourth one states that the pressure is independent of the shape of the container. For as long as the level is the same, it is not influenced by the shape. Number 5, pressure in air is equal in all directions at a specific point, which is similar to Pascal's principle. Pascal's principle again states if a pressure is applied at the surface of the liquid, the pressure will be transmitted in every direction with the same magnitude. For example, application of Pascal's principle, the hydraulic brakes. When you apply the pressure or you apply force on the foot pedal, that force will be transmitted to this piston and it will press down the brake fluid. And this brake fluid will be transmitted into all the wheels with the same magnitude in all directions. One of the learning outcomes that on completion of the topic, the student should be able to describe the atmospheric pressure and apply these concepts in calculations. So atmospheric pressure, which is also called a barometric pressure, it is the pressure within the atmosphere of the Earth. It is the pressure within the atmosphere of the Earth. Or this pressure is the force per unit area exerted against a surface by the weight of the air above that surface. So the symbol that we use to calculate the atmospheric pressure, it will be PATM, which is the short for atmospheric. So atmospheric pressure is PATM, which is short for atmospheric pressure. And this atmospheric pressure, it has a constant value at sea level. It has a constant value of 101.3 kilopascals. Another concept or another type of pressure is called a gauge pressure and absolute pressure. So a gauge pressure is also defined as a pressure at a point. So you'll be calculating the pressure that is exerted by a liquid. A gauge pressure or a pressure at a point is calculated the same way. It is the pressure measured below or above the atmospheric pressure. So this gauge pressure, it gives you the difference between the pressure at a point and the atmospheric pressure. So it excludes the atmospheric pressure. Pressure at a point or gauge pressure excludes the atmospheric pressure. It is the pressure that is measured above or below the atmospheric pressure. But an absolute pressure, which is also called a total pressure on a point, this pressure includes the atmospheric pressure. It is defined as a pressure that is measured above the vacuum. So gauge pressure excludes the atmospheric, but the absolute pressure is the total pressure on a point. It includes the atmospheric pressure. Now let's look at the symbols. For a gauge pressure, we can use PG for gauge pressure, or we can use the formula sheet, will be using the P MET for the gauge pressure, PMET. So this is the gauge or pressure at a at a point. Now, an absolute pressure, the symbol is PABS for absolute pressure. This pressure includes the atmospheric. So it's the total pressure and at a point. So it gives you, it will be calculated by Pmax plus P atmospheric, because it includes the atmospheric pressure. So in other words, the absolute pressure is the gauge pressure plus the atmospheric pressure. It is a total pressure. Now let's first look at formula. Atmospheric pressure, PATM, it has a constant value of 101.3 kilopascal. A kilo is a prefix. So when you multiply it by 1,000, it will be this value in pascals, because kilo is equivalent to 1,000. A pressure at a point or a gauge pressure, it is Pmax. A formula is rho GH. Is the rho GH. Now let's look at this to calculate a pressure in a liquid. Pressure in a point, pressure exerted by a liquid at a point. So if you have a liquid column and it is filled with liquid, the liquid has the mass, and the mass of this liquid depends on the type of liquid that is inside, which is called the density. Also, the volume of that liquid. So the mass is given by density multiplied by a volume. When we make density the subject, density is given by the mass of the liquid divided by a volume. So a mass of a liquid is measured in kilograms, and the volume is measured in cubic meters, because a volume is length times base times a height. So this will be m times m times m, which is a cubic meter. Volume is measured in cubic meters. So the SI unit of a density is kilogram per cubic meter. Now, a liquid, a pressure that is exerted by this liquid, a general formula of a pressure is that it is a force divided by an area over a square meter. So a force will be given by the mass of the liquid, which is m multiplied by the gravitational acceleration, and it's divided by an area. And if where there is mass, we can put the density multiplied by volume. This formula becomes density multiplied by volume multiplied by gravitational acceleration divided by an area. And a volume is given by area multiplied by a height. So a pressure will be given by, where there is volume, is area multiplied by the height. Because length times breadth is an area, then you multiply it by the height. Now, this will be density multiplied by area multiplied by the height, divided by an area, and multiplied by the gravitational acceleration. Area cancels out an area. Then pressure will be equal to density multiplied by gravitational acceleration multiplied by height. So pressure exerted by a liquid depends on these three quantities. It is not influenced by the area. As you can see, area cancels out. So it depends on density, gravitational acceleration, and the height of the liquid. So this is the gauge pressure. It's the one that we use, PMET or PG for gauge pressure. You can calculate it using this formula. Now, if you substitute on the absolute pressure formula, absolute pressure is PMET plus atmospheric. So where there is PMET, if a value for the gauge pressure is given, you put that value there. But if you must first calculate it using the Rho-GH formula, you're gonna take your answer and put it there for the absolute pressure or the total pressure at a point. Plus the atmospheric pressure. Atmospheric pressure is a constant value of 101,3. But if this gauge pressure is in pascals, it means you must also multiply this by times 10 to the power 3 to change it to pascals. You cannot add a pascal and a kilopascal. They must be of the same units. You must get rid of the prefix on that atmospheric pressure. So you always change it to pascals, unless a question says calculate the total pressure in kilopascals. In that case, you need to change the gauge pressure to kilopascals so that you add a kilo and a kilo. Now let's look at the example or the formula. Let's look more on the formulas. This P or this rho is a density. And G is the gravitational acceleration. H is the depth under the water or under the liquid. The total pressure on a point or absolute pressure. So when we calculate absolute pressure is PMET plus atmospheric, which is this plus the constant value of atmospheric, which is 101,3. Now, a force of pressure on a point, you can calculate pressure at a point. So if you make force the formula on the general formula of a pressure, it becomes F equal to PA. The formula, it will be P times area. That pressure is referring to the pressure at a point, which is PMET. We can also calculate the total force. So total force goes with total pressure. Force of a pressure on a point goes with pressure at a point. So total pressure will also use the total pressure multiplied by area. So total pressure is the absolute multiplied by an area. This area must be in square meter. Now let's look at this example. The absolute pressure inside the car tire. So you are given the absolute pressure. It is 235,56 kilopascal. Question says, what should be the reading on the tire pressure, which is gauge pressure? You are looking for PMET, PMET, the gauge pressure. What should be the reading on the tire if you are given the absolute? Now let's look at the formulas that will be given in exam. The absolute pressure will be given. You need to remember the PMET is the gauge pressure, which is also calculated this way. So sometimes you can be given its reading, or you can be given the height, which you must first calculate it. The solution, you are looking for what is the PMET. Formula from the formulas, P absolute pressure is equal to PMET plus P atmospheric. This atmospheric is the constant value of 101,3. So where there is absolute pressure, it will be this given value, which is 235,56 equal to Pmet. You are looking for the gauge pressure, which is Pmet, plus atmospheric is a constant value of 101,3. So this is in kilo and this is also in kilo. You can multiply both by times 10 to the power 3, both by times 10 to the power 3 to change to pascals. Now to make Pmet the subject, Pmet, which is the gauge pressure, will be 235,56 times 10 to the power 3. You take this one over minus 101,3 times 10 to the power 3 will be equal to. So these pressures, if they are in kilopascal, they must be both in kilopascal, or they must be both in pascals. So it is 235,56 times 10 to the power 3 minus 101.3 times 10 to the power 3. And the answer is 134. The answer is 13426. 134,260 pascals, or is 134,26 kilopascals. That is the answer. Let's look at the second example. So this table will be given in exams. If you need the density and it's not given on the question, you come to the table, you're gonna get the density will be listed there. It's 1,000 for water, is 1,000 kg per cubic meter. Now let's look at this. A pressure can also be measured in bars. It says how many bars is 720 millimeter Hg. Hg is the chemical symbol for the mercury. If the density is 13600 kg per cubic meter, 13,600 kilograms per cubic meter, then it says assume 1 bar is 10 to the power 5. So to convert a pressure from bars, this simply means convert this pressure from pascal to bars. From pascal to bars. How many bar is 720? So we must first get what is this in pascals. The pressure is given by rho G H. So this rho must be in kg per cubic meter. And this G must be in meters per second squared. And the height must be in meters. So if the height is not given in meters, you always convert it to meters. So these are the only SI units that will give you a pressure when you use this formula. Kg per cubic meter, G meters per second squared, and the height must be in meters. Now let's go back to that question. How many bars is 720 mercury? So the height of the mercury is 720 millimeter Hg. and the density of mercury is 1,013,600 kg per cubic meter. And it says 1 bar is equal to 10 to the power 5 Pascal. So let's first calculate what is this mercury in pascals. So in Pascal, to calculate the pressure in a liquid, it is given by rho GH, and a density is given is 13600 multiplied by 9,8 on X, then multiplied by, you are given the height of this mercury is 720 millimeter, but it must be in meters. So to change from millimeter to meters, you divide by, you move 3 times. So this will be 0,72. You use your calculator to get what is this in pascals, because you're going to get a pressure that is in pascals. 13600 multiplied by 9.8 multiplied by 0,72. So I got 95961, 95961, comma 6. So SI unit of a pressure is a Pascal. It is in Pascal. To change from millimeters to meters, you divide by 1,000. This is how I got to the 0,72. Now, we must change this to bars. What will be this in bars? It says 1 bar is equal to 10 to the power 5 pascals. But we want to convert 95961,6 pascals into bars. So let me just put X to this side. So when we cross multiply, or let me put this pressure P in bars. So when we cross multiply, this will be this pressure that we want in bars multiplied by 10 to the power 5 pascals equal to, we cross multiply this side. This will be 1 bar multiplied by 95961,6 pascals. So this is for the unknown, because we don't know what is this 95961 in pascals. Next step, we divide by 10 to the power 5 pascals both sides. Divide by 10 to the power 5 pascals both sides by 10 to the power 5 pascals. So this pascals cancels out. 10 to the power 5 cancels out. This side you are only left with P or X, the unknown. The unit Pascal cancels out Pascal. So the answer we're gonna get will be in bars. So we divide this value by 10 to the power 5. It will be 0,9596. 95, or it can be 0, let's round off to 0,96 bars. So this is the answer in bars. Zero comma 96 bars. Let's look at another example. A container full of water has a mass of 10,000 kg and a volume of 10 cubic meters. The height of the container is 500 millimeters. Calculate the gauge pressure at the bottom of the container. So the formula to calculate a gauge pressure is rho GH. M is 10,000 and the volume is 10 cubic meter. So let's look at the The height is 500. Okay, let me just write down the given. H is equal to 500 millimeter. And M is 10,000 kg. Gauge pressure, it says calculate gauge pressure. So gauge pressure is P max, which is given as rho G H. It says it's water. So density is not given, but you go to the table. The table density of water is 1,000. Once you get the density of water as 1,000, you substitute. This will be 1,000 here, multiply G. Even if you don't know what is the value of G, you go to the same table. Gravitational acceleration is 9.8. It is given there. So it is 9,8 multiplied by, this height must be in meters, so it will be 0,5 meters. Divide it by 1,000, is given in millimeters. You use the calculator to get the answer. So this question has nothing to do with volume. This question has nothing to do with area, but it has something to do with the pressure. So it is M, which is 1,000 multiplied by 9,8 multiplied by 0,5. So it is 4,900. It's 4,900 pascals. That is the pressure. So if you want to calculate volume first, you're still gonna get the same answer. Because let's say you are not given the table and want to calculate the density of water. Density is given by mass over a volume. So density is the unknown, but mass is given as 10,000. Then you divide. The volume is given in the statement. The volume is 10. So when you divide it by 10, so it means for this question paper, the density was not given. So if you divide this by 10, density will be, the answer will be 1,000 kg per cubic meter, which is the value that I got from the table. So when the density is not given, you can use a formula to calculate it. Or if you know that density for water is 1,000, you can just apply it in the calculation. Last example, calculate the absolute pressure in kilopascal at the bottom of a column of a mercury with a height of 4,000 millimeters. In kilopascals. I like this question. I like this question. The height of this liquid is 400 millimeters. And it says the type of liquid is a mercury. So we must first calculate the gauge pressure. The gauge pressure, which is Pmet, is given by a formula rho GH. Density of mercury is 13600 multiplied by 9,8 multiplied by, if you change this to meters, it will be 0,4. Then this will be equal to, use the calculator to get what is the Pmet first. It's 13600 times 9.8 times 0.4, and the answer is 53312. 53312 point. Oh, that's all. It is in pascals. Now it says calculate the P absolute. P absolute in kilopascals. So the formula for absolute from formulas, it is Pmax plus P atmospheric. So this must be in kilopascals because this one is in kilopascals. When you change it to kilopascals, you divide by 1,000, this will be 53.312 kilopascals. So you just substitute 53.312 plus the atmospheric pressure is 101.3. You use your calculator to add the two. Plus 101.3. It is 15461. 154.612 kilopascals. So the question says calculate it in kilopascals. Now you can be asked to calculate the height and you'll be given this side and you just substitute and manipulate the formula. Make sure that the pressure is in pascals when you're looking for the height, because we'll end up getting the height in kilometer. So change the pressure to pascals and calculate the height. Thank you.